Okay, final installment for ChemQuest 30, which is the last couple of pages. Go practice 1 through 5. Just as kind of an overview of everything we did in the rest of the ChemQuest on the critical thinking questions. Okay, we're going to move a little faster because I've already done a lot of instructions, so I'm not going to go back to square zero and re-explain everything, but I'm going to walk you through sort of a think out loud as I go through these. So let's begin with number 1. All right, it says to consider the reaction in which 410 grams of calcium nitrate react with just the right amount of lithium metal in a single replacement reaction. So notice we don't have step 1, which is the balanced reaction. All right, so we're going to have to write that down up at the top here, which means you're going to have to go back to your Unit 5 knowledge, right? So we have lithium metal replacing calcium metal in this reaction. So again, I'm not going to reteach you how single replacement reactions work, but we have lithium plus calcium nitrate, right? Now, it's a single replacement reaction, so metal will replace metal, so we're going to produce calcium and lithium nitrate. Okay, lithium is +1, nitrate's -1, so we don't bring that 2 over. Now I need to go back and balance. I have 2 nitrates and 2 calciums, so I'm going to have to go with 2 there to balance out the nitrate, 2 there, and then I'm going to have to go with 2 here to balance that out. Again, I just did that quickly, but that's a Unit 5 skill, and I don't have time in this video to reteach you all of Unit 5. You should have learned this a month ago. All right, anyways. So we have our balanced reaction. So that part's done. So now we're just going to pick up with our mole calculations. How many grams of lithium are required? So I have 410 grams here, right? I want to know how many grams of lithium we need to use up all of that calcium nitrate. All right? So we're going to have to go through stoichiometry, start to finish. Started with our balanced reaction. We're going to take our known quantity, which is 410 grams, and convert it to moles of CaNO3(2). All right, and to convert grams to moles, we divide by the molar mass, and molar mass of calcium nitrate. So 1 calcium plus 2 nitrates. Sorry, I just realized I made a mistake there. There should not be a 2 there. Back at it, excuse me. So 400 grams of calcium nitrate, so 1 calcium plus 2 nitrates gives me a mass of 164.10 grams of calcium nitrate per mole. All right, I'm going to cancel out my grams, and I'm going to get, see, my calculator says 2.498, and I get 2 sig figs to work with there, so I'm going to go 2.5 moles of calcium nitrate. Okay? So, we have that many moles of calcium nitrate. Now, this number is going to be used for the rest of my calculations, right? Using my mole ratios for the other items, right? But here, I want to know lithium, okay? So I know my moles of calcium nitrate. So I'm going to multiply by my mole ratio for calcium nitrate to lithium, which is a 1:2 ratio. So we'll write this out. So 2.5 moles CaNO3(2) times, let's set up my ratio, moles of calcium nitrate on the bottom, because that's our starting quantity, and moles of lithium on top, because that's the number I'm trying to calculate. Lithium has a 2, calcium nitrate a 1. So 2.5 times 2 over 1 gives me 5.0 moles of lithium, right? And then I'm just going to convert moles to grams of lithium, so I'm going to go 5.0 moles Li times the molar mass of lithium, which is 6.94 grams Li per 1 mole. cancel out my moles, and I get a grand total of 35 grams of lithium when I round to 2 sig figs. All right. Now, how many grams of each product can be produced? So we have calcium as a product, and we have lithium nitrate as a product. So we're going to do 2 separate stoichiometry questions. Already have that number calculated. So we already did steps 1 and 2. We're just going to move on to steps 3 and 4 for both of these calculations. So let's go calcium. Okay, and what we're going to do that, we're going to take my 2.5 moles of calcium nitrate times my mole ratio. So mole CaNO3 2 moles of calcium, and that is a 1-to-1 ratio. So I actually end up with 2.5 moles of calcium. All right, and then if I have 2.5 moles of calcium, I'm going to multiply that by the molar mass of calcium, which is 40.88. Sorry, that is 40.08. Fix that. And that gives me 98 grams of calcium. Okay? Now, let's move on to the next one for lithium nitrate. LiNO3 is my other product. Okay? So, I have 2.5 moles of calcium nitrate. All right, I'm going to multiply that by my mole ratio. So again, it's 1 mole calcium nitrate on the bottom and 2 moles lithium nitrate on the top, because the coefficient for lithium nitrate is 2. So I'm going to have 5.0 moles of lithium nitrate. And I'm going to take my moles of lithium nitrate times the molar mass of lithium nitrate, which is 68.95 grams LiNO3. Cancel out my moles, and I get, my calculator is telling me 344.75, but I only get 2 sig figs, so that's going to be 340 grams of lithium nitrate. All right, moving on. Number 2, they give you a balanced reaction, so say thank you very much to the ChemQuest people. But so we're going to pick right up at step 2. Okay, so we have 250 grams of sodium sulfate, right? Reacts with plenty of calcium phosphide according to the following, how many grams of Na3P? So I'm going to go question mark grams. I only have to do one stoichiometry question here. All right, so if I have 250 grams of sodium sulfate, how much sodium phosphide do I get based on this reaction? So step 2, convert known quantity to moles. 250 grams Na2SO4. Okay, I'm going to divide that by the molar mass of sodium sulfate, which is 142.05 grams per mole. And that gives me, when I round to 2 sig figs, I can see my calculator says 1.759, but I only get to go to that second digit, so that's going to be 1.8 moles of sodium sulfate. All right. Step 3, I'm going to multiply by my mole ratio, so 1.8 moles Na2SO4 times my ratio, and moles of sodium phosphide on top, and I have a 3 to 2 ratio, so 1.8 times 2 over 3. I get 1.2 moles of Na3P. All right. Now I want this in grams, so I have one more step to convert to my desired unit. So 1.2 moles of Na3P times the molar mass in this case, which is 99.94 grams Na3P per 1 mole. And that gives me a grand total of 120 grams Na3P. And I round to 2 sig figs. All right, moving on. Number 3. Again, thank you, ChemQuest folks, for balancing our reaction for us already. All right, so here's our balanced reaction right here. So check for step 1. Right? It says we have 75.3 grams of butane. 75.3 grams of this guy right here. Right? We're going to find the amount of both products. So question mark grams and question mark grams. In this case, we're going to do 2 separate stoichiometry questions, but we get to first do step 2, which is convert our known quantity into grams. So I'm going to go 75.3 grams C4H10 divided by my molar mass, which is 58.14 grams per mole. Oops. And I get big, long, ugly decimal 1.29514, and I need to round that to 3 sig figs because I have 3 there, so 1.30 is how I round that, moles of butane. All right, so now I have this number, and I can use that with mole ratios and with molar masses to figure out both of these, right? So for step 3, I'm going to separate this into 2 separate questions. So I'm going to go CO2 and water, right, and map those out separately. So I have 1.30 moles of butane. I multiply that by the mole ratio of butane to CO2. So mole C4H10, and the coefficient for butane is 2. And then moles of CO2 on the top. The coefficient for CO2 is 8. So I'm going to go 1.30 times 8 over 2. Right? And I get 5.20 moles of CO2. And I'm going to do the same thing for water. 1.30 moles of C4H10 times my mole ratio. Coefficient for water is 10. And I get 6.5 moles of water. All right. And in step 4, we want to know the mass. So we're going to go to grams. So again, CO2, water. I have 5.20 moles of CO2 times the molar mass of CO2, which is 44.01 grams per 1 mole. And that gives me 229 grams CO2. And then 6.50 moles of water times 18.01 grams per mole. And that gives me 117 grams. H2O. Boom. 4. Calcium nitrate, aluminum chloride react again. Step 1. Balanced chemical reaction already done for us. All right. If we have 210.5 grams of calcium nitrate, what is the mass of each product? So question mark grams, question mark grams. Okay. So step 2, convert known quantity to moles. So 210.5 grams CaNO3 to divided by the molar mass of calcium nitrate, which is 164.10 grams per mole. All right, and that equals 1.283 moles of CaNO3 2. All right, and we can use this number, and I get 4 sig figs in this number, so I can be a little more precise in my numbers this time. All right, so I can use this number of moles, right, repeatedly to get my various quantities of products. All right, so step 3, we're going to multiply each of these by the mole ratio. So I have 1.283, so we got product 1 is aluminum nitrate. AlNO3, 3. And our other product is calcium chloride. All right, so I'm going to take my 1.283 moles of CaNO3, 2, times my mole ratio, which is 3 CaNO3, 2 AlNO3, 3. All right, this is moles. All right, and that's going to give me 0.8553 moles of aluminum nitrate. And do the same thing down here, 1.283 moles CaNO3, 2 times my mole ratio of calcium nitrate to calcium chloride, which is 3 to 3. So I'm actually going to end up with the same number. And that gives me 1.283 moles of calcium chloride, so that in step 4, converting to my desired unit, which is going to be grams again. So AlNO3, 3, CaCl2, oops, don't need those parentheses there, getting in a hurry. So 0.8553 moles of aluminum nitrate, AlNO3, 3, times the molar mass of aluminum nitrate is 213.01. Cancel my moles. That gives me 182.2 grams of aluminum nitrate. And then for calcium chloride, it's 1.283 moles CaCl2 times my molar mass of calcium nitrate, which is 110.98. And I get 142.4 grams calcium chloride. All right, last question. Number 5. Uh-oh. no balanced reaction force. We've got to go step 1. We have calcium carbonate, so CaCO3. Aluminum fluoride, AlF3. All right, so we're going to go CaCO3 plus AlF3, right? Our two metals will swap places, so we're going to go CaF2 and Al2, CO3, 3, which means we're going to need, let's see, 2 there, and 3 there, and 3 there. That balances it. So step 2, convert known quantity to moles, which is 53 grams CaCO3, divided by the molar mass of calcium carbonate, which is 100.09 grams per 1 mole. Oops. And that's going to give me 0.536 moles CaCO3. All right. We want to know how many grams, so question mark grams here, question mark grams there. Step 3, CaF2 and Al2, CO3, 3. We're going to multiply by our mole ratio, 0.536 moles CaCO3 times ratio CaCO3 Al2 CO3, 3, and we have a 3:1 ratio. So 0.536 times 1/3. We get 0.179 moles of aluminum carbonate. Excuse me, I swapped these around. Sorry about that. And then I got 0.536 moles of calcium carbonate again, times, so I'm going to go moles CaCO3 times moles CaF2, and we have a 3:3 ratio, so it's just going to still be 0.536 mole CaF2. All right, last step, almost done here, you guys. So we have Al2 CO3, 3. We want to convert that to grams, so 0.179 moles Al2 CO3, 3 times the molar mass of aluminum, which is going to be a big, bold number, 233.9 grams per 1 mole. And that gives me 418 grams. That is not right. 41.8 grams. Al2 CO3, 3. One answer, last one, for CaF2, 0.536 moles CaF2 times molar mass of calcium fluoride, which is 78.08. And I get 41.9 calcium fluoride.